Forget everything you learned about traditional financial modeling. Seriously, toss it. Let's bypass all that textbook fluff and look at how top-tier quants are actually using machine learning to navigate today's absolutely chaotic markets. If you're still relying entirely on basic linear regressions to find alpha, well, you're basically trading with a blindfold on. Welcome to The Explainer. Let's pop the hood on the modern quantitative machine.
So here's the fundamental issue we run into. Traditional stats, they demand these perfectly normal distributions and nicely behaved data. It's like trying to force a wild river into a perfectly straight pipe. The real-world markets just do not care about our neat little assumptions. They are messy, highly dimensional, and ruthlessly nonlinear. That's exactly where machine learning steps up, because it doesn't force the market into a rigid mathematical box. Instead, it actually learns the true shape of the data.
Section 1, the end of traditional stats.
Okay, before we dive deep, we need to get our vocabulary straight so we can actually think like quants. First up, we have target variables. This is your outcome, the thing you actually want to predict. Maybe it's a continuous future stock price or classifying whether a specific bond is going to default. On the flip side, we have features. These are your inputs, the raw materials you're feeding into the algorithm, like interest rates, PE ratios, or even unstructured stuff like sentiment scores.
Now, looking at this matrix, it's kind of wild, right? Just look at the sheer volume of algorithms we have at our fingertips. But you don't just close your eyes and pick one at random. Your choice is entirely dictated by the data itself. Is your target variable continuous or categorical? Are your features linear or complex? Think of this matrix as the ultimate architect's blueprint for model selection.
Section 2, supervised learning, the guided missile.
I like to think of supervised learning as a literal guided missile. We feed the algorithm a bunch of historical ground truth, the known winners and losers, and we tell it, hey, go find the patterns. Top analysts deploy these specific algorithms strategically based on the battleground. Got bloated data? Use penalized regressions to drop those useless, non-performing features. Need to make a hard binary call, like classifying a debt issuer as safe or likely to default? Deploy a support vector machine to draw a strict boundary. And for those really complex, nonlinear decisions, like predicting IPO success, random forests are absolutely your weapon of choice.
Section 3, the overfitting trap.
All right, pay close attention, because this is the exact trap where amateur analysts completely blow up their portfolios. Overfitting. It happens when you feed the model way too many features, and instead of finding the true signal, it just memorizes random historical noise. Your in-sample R-squared looks like absolute genius on paper, but the second you trade it live, total disaster. To beat this, we do two things. Step 1, complexity reduction. We mathematically penalize the model for being bloated. Step 2, k-fold cross-validation. This is where we repeatedly train the model on just fractions of the data and test it on unseen parts. It forces the model to actually learn the market structure, not just memorize yesterday's price action.
Section 4, unsupervised learning, the radar.
So if supervised learning is our guided missile, unsupervised learning is our radar. It's constantly pinging the environment, trying to find hidden structures. And here's the kicker. We have absolutely no target variable, no ground truth. When you're analyzing thousands of securities, the sheer dimensionality can literally blind you. So we use principal components analysis, or PCA, to compress hundreds of noisy, correlated factors into just a few highly informative eigenvectors. Then we use clustering. Instead of relying on rigid, outdated Wall Street sector labels, we use k-means clustering to group stocks based on actual mathematical similarities. It reveals how the market truly trades underneath it all.
Section 5, neural nets and deep learning. Okay, let's level up. When the nonlinearities in the market become incredibly severe, your standard algorithms just aren't going to cut it. Enter neural networks. Now let's be clear, they aren't magic, they're just advanced statistics. Think of them as interconnected information processing nodes structured in layers. You've got an input layer, hidden layers, and an output layer. The neurons in those hidden layers calculate a weighted average of inputs, pass it through a nonlinear activation function, and then, here's the cool part, they actually tune themselves by learning from their own prediction errors using forward and backward propagation. And this right here perfectly illustrates their raw power. In one study, they fed a deep learning network just the 6 standard inputs of the classic Black-Scholes model. The result? It predicted option values with an R-squared of 99.8%. I mean, that is insane. Deep learning nets can process severe nonlinearities so efficiently that they absolutely obliterate strategies relying on standard factor models. Section 6. The ultimate market edge.
Now, theory is great and all, but let's be real, Alpha is better. Let's look at a massive real-world application for all this. ESG investing. See, governance is pretty easy to track, but social and environmental impacts, super subjective. So top analysts don't just sit around reading annual reports anymore. They use natural language processors to parse through massive amounts of unstructured corporate disclosures at scale. They're hunting for very specific keywords like human capital, living wage, or green, converting those to features and feeding them into supervised models like random forests. The result? They generate these highly accurate, entirely proprietary ESG factor scores that the rest of the market doesn't even have access to. That's your edge.
But here's the ultimate takeaway you need to remember. Yes, the algorithms are undeniably powerful. A neural net processes data at speeds we literally can't comprehend. But at the end of the day, it's the analyst's judgment that actually generates the alpha. The machine itself doesn't know which features matter fundamentally to the broader business cycle. You do. Defining the hyperparameters, choosing an SVM over a random forest, properly interpreting the output, that is where the real value is extracted. The algorithm is just the tool. You are the master. Which brings us to this final thought. Look around. Markets are definitely not getting simpler. They are becoming infinitely more complex and highly dimensional. So you have a choice. Are you going to continue relying on outdated statistical assumptions that try to force the entire financial world into a neat little bell curve? Or are you ready to leverage machine learning to find the hidden structures of tomorrow's markets? The tools are out there, waiting for you. It's time to build.